We're completely surrounded by these perfectly printed images on our phones, our cars, even our t-shirts. But have you ever really stopped to think about how they're made with such incredible razor-sharp precision? Well, the answer isn't just about ink. It's a technology that literally prints with pure light. So let's dive in and see how it all works. Right? I mean, how do they get that logo on your coffee mug just so? Or the intricate design on a shirt without any smudges? The secret isn't just some fancy ink. It's a truly revolutionary process that uses these industrial screens, and you're not going to believe this, pure light to get that flawless clarity. But, okay, before we get to the really cool, elegant solution, we have to understand the messy problem it solved. For decades, getting screens ready for industrial printing was a slow, complicated, and honestly a pretty imprecise process. Yeah, the old way was a constant battle. You were dealing with physical materials like ink and wax and film. It meant messy chemical processing, painstaking manual touch-ups with a magnifying glass, just so many complex steps. But the digital approach, it completely changed the game. It threw all of that out and replaced it with one simple, powerful tool: direct light. And that means no more consumables, you get perfectly seamless results, and the whole process is just so much simpler. And this brings us to the breakthrough moment. A company called CST developed a technology that just completely sidestepped all the old problems, offering a solution that was cleaner, way faster, and far more precise. I mean, listen to this. Easier, faster, more cost-effective, and higher quality. That's pretty much the holy grail for any industry, right? So the real question is, how on earth did they actually pull it off? The big idea is just so elegantly simple when you think about it. Instead of physically blocking out parts of a screen with stuff like wax or film to create a stencil, you use a precisely controlled beam of UV light to essentially draw the image directly onto the screen's coating. You are literally printing with light. So, how do you control light with that insane level of precision? Well, this is where the real magic happens. We've got to go deep inside the machine onto a tiny little chip. It's called a digital mirror device, or a DMD for short. Now, I want you to imagine a semiconductor chip, but its surface is covered with up to 2 million, yes, 2 million microscopic mirrors. And each one of these tiny little mirrors can be individually controlled to either project or block a super powerful beam of UV light. So each one of these microscopic mirrors basically acts like a single pixel in the final image. They tilt thousands of times per second. I mean, it's just mind-bogglingly fast. They can either reflect a UV light onto the screen to create part of the image, or they can deflect it away to leave an area dark. This is digital control at a physical, microscopic level. It's incredible. Okay, so here's how it all comes together in a flash. A digital file of the image gets loaded. Instantly, those 2 million micromirrors tilt to match the image data. A powerful UV light flashes on, and the pattern of reflected light exposes a perfect, seamless image onto the screen. And this all happens in a tiny fraction of the time it used to take. And the leap in quality, it is absolutely staggering. Where the old methods really struggled, this digital light exposure, or DLE technology, can achieve resolutions up to an incredible 5,080 dots per inch. Even for something huge, like rotary screens for textiles, it hits a massive 2,400 dpi. We're talking about the difference between a fuzzy, low-quality image and the razor-sharp designs we see everywhere today. Now, this isn't just some cool experiment in a lab. This technology is quite literally printing the world all around us, and its impact is way bigger and more diverse than you might think. Seriously, this technology is everywhere. It's in the intricate patterns on our clothes, the instrument dials in our cars, the tiny circuit boards in our electronics, and the logos on our sports gear. Even super high-security things like authenticity labels rely on this incredible level of accuracy to work. And what's really cool is how versatile the technology is. They've engineered custom systems to handle all sorts of different needs. So on the left, you can see a machine for these big flat screens. Think glass panels or huge graphics. And then on the right, that's a system designed for rotary screens, which are essential for continuous printing on things like fabrics. The adoption of this has been truly global. We're talking over 2,000 of these machines installed for customers in more than 60 countries. So this isn't some niche product. It has become a proven worldwide standard for high-quality screen imaging. So you're probably wondering, who's the company that pioneered all this?
Well, the innovator behind this amazing tech is CST GmbH, a German engineering firm with really deep roots in the printing industry.
You can see in their history a really clear pattern of innovation. They were founded back in '89, and then in 2000, they dropped this game-changing DLE technology on the world. But they didn't stop there. They kept refining it, integrating more official UV LEDs in 2009, and then expanded their global reach in 2021. These guys have been pioneers in this field for decades.
And that really brings us to a final thought, doesn't it? At its core, this technology prints with light. It really makes you wonder, as our tools become more and more precise, as fast and as accurate as a beam of light itself, what incredible new things will we be able to create next?